MVAPICH2 at NERSC. And this will be given by Shahzeb Siddiqui. He's an HPC consultant software integration specialist at Lawrence Berkeley National Lab. He's part of the user engagement team that is responsible for engaging with NERSC's user community through user support, tickets, outreach, training, documentation. He's part of the Exascale project and basically part of the software deployment group, where he's responsible for building SPAC, extreme scale scientific software stack, E4S at DOE facilities. And this work was done with Dr. Samir Shende from University of Oregon and Paratools, and Prathmesh Sambrekar, who was an intern at NERSC. Shahzeb, can you hear me? Are you there?
Okay, hi. For some reason, I couldn't unmute. Can you hear me now?
Yes, Shahzeb, we can hear you.
Okay. Give me a second to get set up. Screen 2. Can you see my screen?
So we see your screen, but it's presenter view. So you can swap your displays at the top.
All right, hold up.
Yep, you're good.
That work?
Yes.
Okay. Okay. So today I'm going to be giving a talk on MVAPICH and NERSC. So my name is Shahzeb. I work at LBNL as a software integration. I'm also part of the ECP group. So some of the things that in the previous talk we were talking about SPAC, I'll briefly touch on SPAC and how MVAPICH relates to some of the work that we're doing. So let's get started. So if you, just an introduction, at least for those of you, I'm sure most of you know NERSC, but in a NERSC, this is it's a scientific computing facility. It's one of the Office of Science labs and part of the U.S. Department of Energy. You know, at NERSC, we support up to 8,000 users, and you know, we have a lot of different types of codes that run on our system, you know, including climate modeling, high energy physics, even protein simulation, and you know, even simulation of the universe. We recently had a supercomputer called Perlmutter. You know, it was named after Saul Perlmutter. He was a Nobel Prize for discovering the rate of expansion of the universe. So generally, you know, we name our clusters behind some, you know, distinguished scientist that has done work. So we'll talk a little bit about Perlmutter if you didn't know. Perlmutter was a relatively new system. I think we stood it up last year. It's an HPE Cray Shasta platform. It's composed of both CPU only and GPU accelerated nodes. On the right is kind of an architectural diagram of the topology. So the system is actually being delivered in 2 phases. The system in total contains almost 1,500 plus GPUs with the A100 and almost 3,000 plus CPUs. That is AMD EPYC Milan. And I took a screenshot of Perlmutter's performance on the top 500. Currently we're at a peak of 93 petaflops, right? And it's just what it is, and most likely we'll after phase 2 we'll have a much bigger system, so hopefully this performance will be even higher. Okay, so just covering some of the recent activities with related to MVAPICH. We published a technical report. The title is really long, but it's basically our software deployment process at NERSC. And I took a screenshot of one of the pages from the technical report, which talks about the MPI support. We're working with the MVAPICH2 team to basically experiment with the MVAPICH2 GDR as an MPI provider to build the E4S stack. And in the bottom half, we actually have like a deployment of MVAPICH2 with what's called a E4S stack that comes with basically SPAC packages that have been installed with MVAPICH2 along with its modules. So currently we build all of our software through our vendor MPI, that's Cray MPICH. And it works for building most of the stack. However, there are like some packages that don't build. So when it comes to those packages that just don't build, users and also us tend to try to experiment with things. And we don't right now have like an alternative solution. So that's why we're trying to find another MPI provider that can help provide users also the ability to experiment with other compilers. So right now with OpenMPI, we have like OpenMPI and basically MVAPICH, and then we have the vendor Cray MPICH that's just provided by HPE. So this is kind of an overview of like our modules. So we have an MVAPICH2 on a shared file system. We don't expose it in the startup module path, but it's available for use. You just have to know the directory path. And yeah, so we have, I think the most recent version, that's the 3.0 alpha. Hopefully we'll get the new official release and then we'll just install it. The way we've been installing this is, we get the RPM, we install it locally, and then we will write the module file for MVAPICH2, and then we use that as part of our SPAC deployment. So I want to talk a little bit about some of the things that I've encountered. I've been building some of the software stack at NERSC, and particularly the E4S stack, for probably this is my 4th or 5th iteration. Basically, each iteration is a whole software stack with like 400 or 500 packages. And over time, I've came across some pattern, some packages that just fail to build. I mean, part of it is just like the lack of support with the software and also within SPAC to build properly with Cray MPICH. We define a Cray MPICH as an external, and then we just let SPAC build. And I just kind of documented 2 of the errors for 2 SPAC packages, REMPI and MPI file utils. Some of them fail at the configure line where it just can't detect the MPI wrapper. And then some of them obviously fail for other reasons where there could be a dependency, and then if the dependency doesn't work, then you can't install the package. In this case, MPI file utils failed on libcircle. It just couldn't find MPI compiler. It's trying to set MPI CC, but on Cray we use the CC, the Cray wrapper CC, capital CC and FTN when invoking MPI program. So some of this stuff, when we run into these problems, we don't have like an easy workaround for this, other than just by experimenting with either the SPAC configuration or just trying another MPI provider. So that's usually what it is. But for the purpose of our deployment, we just try to build as much software as we can, and then just document the error, and then just move on. So it's just a simple example of like how you would use MVAPICH on Perlmutter. So the MVAPICH 3.0, it supports Slurm and Slingshot 11 network interface, so it can be used both on the CPU and GPU nodes. We recently upgraded both the CPU and GPU nodes to Slingshot 11, so this was kind of good timing to have the MVAPICH 3.0. So in order to use MVAPICH, you would just module use this directory path where we keep some of the module files that we have for MVAPICH. You load MVAPICH, and then you can compile a code using the MPI CC. In this case, we have a foo.c, and then you can srun. So that should just work on our system. One of the other problems is just a side note. We also have like OpenMPI, but the OpenMPI that we have, it wasn't built with Slurm. So one of the key things that we need for the MPI provider is that it should be built with Slurm, and then it's Slingshot, because the problem is that the users sometimes they don't know, and they will try to like run the program and with srun, and then they will get runtime errors, and then they just don't know what to do. So we're trying to make sure that we can get the proper support for the systems. That way, users don't run into these problems. We usually get these problems in the forms of user tickets. So yeah. Okay. So the E4S, which is the extreme scale scientific software stack. So we have this installed on Perlmutter. The way you would use this is you would, module use this directory path, and then there is a E4S module. So we have, let's say, E4S 2205 that's built with MVAPICH2. You would load it, and then upon loading it, you would see basically SPAC generated modules for the SPAC packages, along with an instance of SPAC, so you can run whatever SPAC commands you want, including SPAC load to load any software. So we have this documented in the E4S documentation page. So if you want to try it out, it's there. This is what the software looks like. Yeah, so we built, we're using, I believe, LMOD hierarchy. And yeah, we built a lot of the packages, as you can see, from, Adios and yeah, all sorts of packages that come. One thing you would notice is that some of the packages have these suffix. So we distinguish between a specific build, let's say, because we're building optimized for A100, so CUDA 80, that's the CUDA Arch. So you can see, like, for instance, like Tasmanian, it's like built with OpenMP support, same as Strumpack. And then, like, for instance, like you see Slate, that package is built with CUDA 80 and OpenMP, and then there's one that's just built just with OpenMP. So we try to make some of this distinctions in the module file so you can know how it's being built. Yep. These are just some of the directory paths for each of the software and where it's installed. So it's about 74 packages. And also, as part of the MVAPICH2 kind of sanity check, we run the OSU benchmark. So there is a simple test that will just verify kind of the MVAPICH2 performance. So this test is run via build test, which is a HPC testing framework. It just helps automate the build and execution. On the top right is actually the test itself. What we're doing is we're running it on Slurm scheduler. So you see SBatch options, and we're in the run sections. What we're running, these are commands that are injected into the test, where we're saying module use the state and where the module file is, module load and MVAPICH, and then run like the OSU latency, OSU bandwidth, and bidirectional bandwidth. And then I show you kind of some of the performance results that we get. And build test will publish the test results into CDash, so you'll see the results and the metadata associated with each test. So the performance looks pretty good so far, and we hope to get more tests just to make sure that this MPI is working as expected. I think this is my last slide. So yeah. So NERSC will continue to provide support for the vendor MPI. That's the Cray MPICH. But on the contrary, like the users, what they do is they experiment with any of the MPI providers. They just a lot of the times they they just need to install some software, and they look at whatever's available on the system and whatever they can get hands on, whether that's OpenMPI, MVAPICH, or MPICH. And it can be troubling for us to support all of this when we don't have proper support. So one of the things that we're trying to do is see if we can get let's say MVAPICH2 GDR that can potentially work and provide users an alternative to Cray MPICH. Right. So considering that it's support with Slurm and also Syncshot 11 sounds promising. And with sufficient testing, we can potentially open up this MVAPICH2 to the users with documentation and how to use it on Perlmutter. I guess in terms of like testing, like we could try to compare like performance comparison with Cray MPICH versus MVAPICH2, just to see how both of the MPI providers perform on Perlmutter, right? Both on CPU and GPU. Intentionally we don't have MVAPICH2 in our user documentation, along with the eForest deployment that we showed. It's not part of our user documentation simply because when users find stuff on our user docs, they use them, and when they run into errors, then they report those issues into our user ticket, and then it's like additional overhead for us to try to troubleshoot. So the other use case that can be helpful is that a lot of users, since I'm also part of like taking care of user tickets, users try to install software. A lot of times they also install software with SPAC. So right now they're kind of locked into Cray MPICH because that's like the only MPI provider that we support. If they try using like OpenMPI, I think that's the only other MPI that we provide, they're going to run into other errors. Even if they build the software, they'll run into runtime errors because a lot of the software still needs to run on our system with Slurm, and So hopefully with MVAPICH2, we can get more coverage over some of the SPAC packages that fail. So yeah, I think that concludes my talk. And that's it. Thank you for listening.
Sure. So Shahzeb, since this is one of the earlier deployment of Slingshot 11, so how's your experience been with real, HPC and DL applications?
I think it's still too early to say because I haven't. I think those feedbacks have to come from the users.
Oh,
I
okay.
just do the deployment. Yeah.
So they're not complaining so far?
Well, it's mainly because they probably don't know about it.
Oh, okay. So I
Yeah.
think we have a question from the audience. Donglai?
Yeah, I think you showed some of the point-to-point performance per model for MVAPICH2. You must have something from Cray and Pitch, right? Those numbers, does that look good?
Yeah. Those numbers seem to look expected to what our node performance should be.
Okay. Another thing I would like to ask is I happen to use Paramata for some time. And Cray stuff require their own compilers. Okay. And sometimes specific optimization was applied to their compilers, but not necessarily the kind of optimization that I have control with. So sometimes I use GCC, more general part. And those ones seems to work. I seem to have a better control on like a MVAPICH2 rather than Cray's stuff, because a lot of that is not necessarily open. And second, it's not well documented, what kind of operations or optimizations I potentially can use. So do you have any suggestions or recommendations for that?
Yeah, I mean, we recommend all the users to use the Cray wrappers. If you use the GCC wrappers or any other compiler wrappers, you're gonna run into other strange issues that usually it's just better if you're using any of the program modules, then you have to use the Cray wrappers.
Oh, okay.
That will get you the better performance. But if you're using like some stock compiler that you built yourself, or like Intel with another MPI provider, then yeah, then you would obviously have to use the appropriate wrappers. Like you still have to use MPI-CC for compiling, like if you're using OpenMPI. But if you're using Cray and Fish, you have to use the CC. Because the thing is, MPI-CC is not like available on the system. Like when you go on Perimeter,
Yeah.
you'll see Cray and Pitch is loaded, but when you look at it, you will not see MPI-CC as a wrapper. It's kind of intentional because you want to compile with the Cray wrappers.
Okay.
But you can find the path and then kind of use it, but it's going to cause some weird issues because you have like applications like Makefiles and other things. They're expecting like MPI wrappers.
Yeah. Okay.
So
thank you.
We're trying to tell them to switch to capital CC, lowercase CC, those Cray wrappers.
Okay. Now, I think our model will start to charge beginning of next month, right? So is that the model moving forward? You stick with the Cray related tool chains only?
Yes, if you want to. I mean, yes, I would say you should use the Cray wrappers.
Okay.
Program GNU and Program Cray should work pretty well. The state of Program NVIDIA / Program MVAPICH2 is like in the middle of switching. Right now, like originally it was Program NVIDIA, and I think HP is switching to Program MVAPICH2. So right now we have both, but
Okay. Thanks.
So we have another question in the audience. Yeah, please go ahead.
Yeah, I'm just wondering, like, is there any specific modification that's done to spec or a compilation process if there is a lightweight virtualization involved, say, container, like I want to run MPI and stuff within a container? Is there any on a machine that on a supercomputer machine that NERSC would manage? Like, yeah.
at the moment we're in the process of getting Podman set up on Perlmutter, so that way users can build containers, use containers. Right now we have Shifter, which can be used to pull in an image and any container and then run them on Perlmutter. But in terms of the like the E4, like kind of like the E4S software, we do have a container that's available provided by E4S team the users can use, along with the MPI inside the container. But at the moment, it's not ready for use.
So, but basically, in that kind of scenario, NERSC would provide their own containers or images for use.
Yes.
Okay.
There is a repo that we have that provides like I would say you could say official images that NERSC provides. These are images that our staff build and provide to the users. Obviously, there's going to be other images that you can pull in. We have a container registry. I think you may have already known if you've used Shifter. I think it's called registry.services.nersc.gov or something like that. So you will see all the images there.
Cool.
Thank you. Thank you.
Okay. So, Shahzeb, can you say more about this build test software? Is this an in-house testing framework?
Yeah, so build test is an open source project available on GitHub. It's a testing framework. It's developed in Python, and the way it works is that it uses YAML as a templating for writing tests and converts them into shell scripts, and it has like integrations with the scheduler so you can auto submit jobs, pull the results, and get the results, and then publish the results into C- and other things. I guess if I just do brief overview, like the project is right here. This is the documentation. There is a GitHub. That's the open source version. So you can just clone the repo, and we have a link over here, which is the test. So if you were like curious to see like where this test come from, so this is like basically a repo of all tests that that we run, including a lot of the E4S tests and the MVAPICH2. So like the MVAPICH2 test, we have it under apps. Like we have a bunch of other software like OpenMPI, OpenMP, and then like I think this test was this one right here. A lot of the software actually gets run using GitLab, it runs a subset of the test. And then we have, let's say, I mean, this is just a very quick overview, but we publish all the test results to CDASH, which I'm trying to find the link. Yeah, this thing. So over
Shahzeb, I
here,
have a
you see all
question.
the,
Sorry.
yeah, you see the test results over here. So you can see the MVAPICH2 test right here. And you see the test results, like the user, the command that was run, and the kind of the output, all of this, the script, and then even the job data. So this is kind of a brief overview. Go ahead.
I have a question regarding this test suite. So how detailed should one be when they are launching their test? Like, do you need to specify the entire command for the test, or it's possible to change the parameters like the MPI launcher and the number of nodes and processes and whatnot?
Yeah, you can go as detailed as you want. The tests are intended to be written in a way where it's fully customized, and the developer, I mean, the one that's going to be writing the test, they can specify all of their arguments, like the SBATCH directives, and then, in this case, you have to know our system, how to run a job, the queue. So you can be as explicit as you want. So, and then obviously if you're using MVAPICH2 in this case, we use srun.
Thank you.
I have a couple questions about build test as well. So build test looks like a very powerful tool, notably for automating OSU micro benchmarks. Can I use build test to hot swap module versions, such as if I wanted to change out the different MPIs and OSU micro benchmark builds?
Yeah, you can.
And is that configured in a single file, or do I create multiple build tests?
You can create multiple tests. You can run a test across like multiple compilers. So I think if you're looking at the documentation is quite extensive, but the way the tutorial is set up is there is the command line tutorial for build tests, which is like, I mean, if you go through it, it'll be like, you'll get a pretty good understanding of the command line interface. But if you're running the tests, so if you need to write the test, which is called a build spec, you go in here and then you would see everything that you need to know about writing a test. And yes, we do support running a single test across like multiple compilers, across multiple queues. So yeah, it is possible.
Okay, and then following that, so SPAC integrates in with build test?
Mm-hmm.
And
Yep, we have that.
Great. So we'll just have, take one more question.
Yeah. So we've obviously done some performance analysis on Perlmutter, testing out the MVAPICH2 support for Slingshot 11. And we've noticed both with MVAPICH2 and with CRAMPitch that sometimes we'll see on the same allocation, we'll see peak bandwidth in one run, followed by just a inexplicable drop to half bandwidth in another run. Are you guys taking a look at that at all, or is there any sort of testing that you've been doing to give us some kind of insight as to why we might see that?
That's interesting. I think it will be helpful if we can. So if I were to do this, I think I mean, presumably you ran this on a node exclusively without any other users running jobs. Right?
Yeah, that's correct. These were exclusively allocated and made sure to run within the same allocation. So I thought it was something with the congestion control or something like that.
Yeah, I mean, Yeah, I think if you are running into these problems, it would be helpful to see those test results. If you even have a test, you're welcome to contribute those tests, and then we can have those tests, just run the test, and then we just have it run like every day or so and monitor the test results. I'll be curious to pinpoint if it's like a specific node, just to troubleshoot. You know, we can have the test with a host file specify so that it just runs on 2 nodes. If you need to go even further, we can request a reservation and perform the test over there, just to troubleshoot.
Okay,
And
thanks.
I'm already over 10 minutes.
Right. So let's thank the speaker and let's look forward to, having MVAPICH2 as an option on Perlmutter 2 for the users. Thank you.
Thank you.
So we have a lunch break now, so we'll resume at 1:30 p.m. and we have a keynote talk by Dan Stenzioni, Texas